Hello students, welcome to my channel. In this class I am going to teach you derivative of a function by first principle or by definition. Let us solve few problems by which this definition and how to find the derivative of a function will be more clear to you. So let us start the topic. Derivative of a function definition. A function f of x is said to be differentiable at a point x if limit h tending to 0 f of x plus h minus fx divided by h exists. The question is find f dash of x where fx is equal to e to the power a x plus b by first principle or by definition. So here fx is equal to e to the power x plus b. F of x plus h is equal to e to the power x plus h plus b. Here x is replaced by x plus h. Here in the left hand side x is replaced by x plus h. In the right hand side in place of x we have written x plus h. Now f dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. So this is equals to limit h tends to 0 e to the power a into x plus h plus b minus e to the power a x plus b by h is equal to limit h tends to 0 a x a h plus b. We have multiplied a here with x plus h minus e to the power a x plus b divided by h. So this is equals to limit h tending to 0. We can take e to the power x plus b common. So that e to the power a h minus 1 divided by h. So here e to the power x plus b outside. Now limit h tending to 0 e to the power h minus 1 divided by h. Okay, so we are taking e to the power a x plus b common. So this can be written as e to the power a x plus b limit h tends to 0 e to the power a h minus 1 into a by a h. So this is equals to a e to the power x plus b. Limit h tends to 0 e to the power h minus 1 by h. Put t is equal to h. So we are taking here t is equal to h. If h tends to 0, then t tends to 0. So this becomes a e to the power x plus b limit t tends to 0. Limit t tends to 0. E to the power t minus 1 by t. So this is a e to the power x plus b. This is ln e, which is equals to a e to the power x plus b into 1. So this is equals to a e to the power ax plus b answer. So here limit t tends to 0, e to the power t minus 1 by t is equal to ln a. So we should remember limit x tending to 0, e to the power x minus 1 by x is equal to ln a. So thus this formula we have to remember. So our first problem is now solved. Let us proceed to solve the next problem. Find f dash of x where f of x is equal to a to the power x by definition. Solution. Here fx is equal to a to the power x. F of x plus h is equal to a to the power x plus h. Now we have to find f dash of x. This is equal to limit h tending to 0, f of x plus h minus f of x by h. So this is limit h tending to 0, a to the power x plus h minus a to the power x by h. Limit h tending to 0, a to the power x common, a to the power h minus 1 by h. So this is equal to a to the power x. Limit h tending to 0, a to the power h minus 1 by h. This is equal to a to the power x ln a. Since limit x tending to 0, a to the power x minus 1 by x is equal to ln a. So this is answer. So here fx is equal to a to the power x, f of x plus h is equal to a to the power x plus h, because here x is replaced by x plus h, x is replaced by x plus h. Now we have to write the formula for f dash of x, which is equal to limit h tending to 0, f of x plus h minus fx by h. Now limit h tending to 0, a to the power x plus h minus a to the power x divided by h. Now we can take a to the power x common, so that a to the power h minus 1 by h. A to the power x here, then limit h tending to 0, a to the power h minus 1 by h, which is equal to ln a. Our next question is find f dash of x where fx is equal to ln x by definition. Now solution. We have to find f dash of x where fx is equal to ln x. So here fx is equal to ln x, f of x plus h is equal to ln of x plus h. Now f dash of x is equal to limit h tending to 0, f of x plus h minus fx by h. So this is equal to limit h tending to 0, ln of x plus h minus ln x divided by h. So this is limit h tending to 0, 1 by h ln of x plus h minus ln x. So this is equals to limit h tending to 0, 1 by h ln of x plus h by x. Because we know ln a minus ln b is equal to ln a by b. So this is equals to limit h tending to 0, 1 by h ln of 1 plus h by x. This is ln. So this is equals to limit h tending to 0 ln of 1 plus h by x to the power 1 by h. So this is equals to limit h tending to 0 ln of 1 plus h by x to the power x by h into 1 by x. So then this is equals to limit h tending to 0, 1 by x ln of 1 plus h by x to the power x by h. So put t is equal to h by x. If h tending to 0, then t tends to 0. So this is equal to 1 by x ln limit t tends to 0, 1 plus t by 1 by t. So this is equal to 1 by x ln, this is e. Since limit t tends to 0, x tending to 0, 1 plus x to the power 1 by x is equal to e. So this is equal to 1 by x into 1 is equal to 1 by x answer. So here in this question, fx is equal to ln x. Here this x is replaced by x plus h, and here this x is replaced by x plus h. Now f dash of x is limit h tending to 0, f of x plus h minus fx divided by h, limit h tending to 0 ln of x plus h minus ln x by h. And this is 1 by h, limit ln x plus h minus ln x. This is limit h tending to 0, 1 by h ln x plus h by x, because ln a minus ln b is equal to ln a by b. So limit h tending to 0, 1 by h ln 1 plus h by x. Limit h tending to 0 ln of 1 plus h by x, 1 by h. Because we know r ln x is equal to ln x to the power r. So now limit h tending to 0 ln 1 plus h by x, x by x, 1 by x. So we have adjusted this x, multiplied to the denominator and numerator. Now this is 1 by x ln of 1 plus h to the power x by h, because ln x to the power r is equal to r ln x. So in place of r, here it is 1 by x. Now we are taking t is equal to h by x. If h tending to 0, then t tends to 0. So 1 by x limit ln limit t tends to 0, 1 plus t to the power 1 by t, and this value we know is e. So ln e equals to 1, since ln e is equal to 1. So the answer is e 1 by x. Now let us proceed to solve the next number 4 now. Find f dash of x if fx is equal to sin x by a first principle. By first principle. Solution. Find a dash of x where fx is equal to sin x by a first principle. Here fx is equal to sin x. F of x plus h is equal to sin of x plus h. Now f dash of x is equal to limit h tending to 0 x f of x plus h minus fx by h. So this is equal to limit h tending to 0 sin of x plus h minus sin x by h. So this is equal to limit h tending to 0 2 cos c plus d by 2 sin c minus d by 2 divided by h. Since we know sin c minus sin d is equal to cos c plus d by 2 sin c minus d by 2. So this formula we have applied here. This is c and this is d. 2 cos c plus d by 2 sin c minus d by 2. So this is limit h tending to 0 cos of 2x plus h by 2. This is sin of h by 2 divided by h by 2. So this is equals to limit h tending to 0 cos of x plus h by 2. This is sin h by 2 by h by 2. So this is equals to cos of x plus 0 and this is 1. So which is equal to cos x. So here find f dash of x where fx is equal to sin x by first principle. Here fx is equal to sin x. F of x plus h is sin x plus h. Now f dash of x is the limit h tending to 0 f of x plus h minus fx by h. So limit h tends to 0 sin of x plus h minus sin x divided by h. So limit h tending to 0 2 cos c plus d by 2. This is the formula sin c minus sin d. This is cos c plus d by 2 sin c minus d by 2. C plus d means x plus x by 2 sin x plus h minus x by 2. So this is 2x plus h by 2 and sin of h by 2 by h. So this is x plus 0 and limit h tending to 0 sin h by 2 by h by 2 is 1. So So that is cos x answer. So with this our fourth problem is now solved. Let us proceed to solve the next problem. Find f dash of x where f(x) is equal to ln of 3x plus 1 by definition. Solution. Here f(x) is equal to ln 3x plus 1. So f of x plus h is equal to ln 3x plus h plus 1. Now f dash of x is equal to limit h tending to 0 f of x plus h minus f of x by h. So this is equal to limit h tending to 0 ln of 3x plus h plus 1 minus ln of 3x plus 1 divided by h. So this is equal to limit h tending to 0 1 by h ln 3x plus 3h plus 1 minus ln 3x plus 1. So this is equal to limit h tending to 0 1 by h ln of 3x plus 3h plus 1 divided by 3x plus 1. Because ln a minus ln b is equal to ln of a by b is equal to limit h tending to 0 1 by h ln of 3x plus 1 plus 3h by 3x plus 1. So this is equal to limit h tending to 0 1 by h ln of 1 plus 3h by 3x plus 1. So this is equal to limit h tending to 0 ln of 1 plus 3h by 3x plus 1 to the power 1 by h. So this is equal to limit h tending to 0 ln of 1 plus 3h by 3x plus 1 to the power 3x plus 1 by 3h into 3 by 3x plus 1. So this is equal to limit h tending to 0 3 by 3x plus 1 ln of 1 plus 3h by 3x plus 1 to the power 3x plus 1 by 3h. So put t is equal to 3h by 3x plus 1. If h tending to 0, then t tends to 0. So here we are getting limit h tending to 0 ln of 1 plus 3h by 3x plus 1. So here we have multiplied 3, divided 3, multiplied by 3, multiplied by 3x plus 1, here divided by 3x plus 1. So that put t is equal to 3h by 3x plus 1, wherein t tends to 0, h tends to 0, then t tends to 0. So this becomes 3 by 3x plus 1 limit t tends to 0 ln 1 plus t to the power 1 by t. So this is equal to 3 by 3x plus 1 ln limit t tends to 0 1 plus t to the power 1 by t. So then this is equal to 3 by 3x plus 1 ln e, because one limit t tends to 0 1 plus t to the power 1 by t is equal to e. So this is equal to 3 by 3x plus 1 ln e is 1. So 3 by 3x plus 1 answer. So our fifth problem is now solved. The topic for today's class is completed. I shall meet you with a new topic in my next class. Till then, goodbye.